So we'll continue trying to implement the rest of the array methods. We have already implemented maximum, sum, and member. So let's try to implement a search method. Now the search method is going to iterate over the whole array. If it finds the element, it should return the index of that element. Now for simplicity again, if we do not find the element, we will return -1. So we are returning an integer in either case. Our method should return an integer. So let's start writing our method. So our method is going to be like this: public static, and then return type is going to be an integer, and our method is going to be called search. So for our method, we need to give it an array to perform the search on, and then another integer, which is the integer that we are searching for in our array. So what I need to do here is I need a loop to loop over the array. Now let's look at our conditions that will tell us whether we can use an enhanced for loop or not. Are we iterating over the whole array? Yes. So check on the first condition. Second condition, are we writing anything to the array? No. So we pass the other condition as well. Are we keeping track of the index? The answer is yes, because we need to return the index. So we are not good to go in terms of the last condition. And since not all of the three conditions hold, we cannot use an enhanced for loop. So we will use a regular for loop. So for an integer I that is starting at 0, and while I is less than the length of the array, I will keep incrementing I. Now at every iteration I need to check the element that I'm dealing with. If it's equal to the number, I should return that index. So I need an if statement. In my if statement, I'll say if my number is equal to the array at that position, which is I will go ahead and return the index. So the index is going to be I because I'm at that iteration, I'm dealing with that index. Now if I finish up my loop and I do not find my index or my element, sorry, I need to return -1 to signal that this is not in the array. So return -1. This is how we search an array. Now let's go and test it out on some elements in our array. And since it's returning an integer, so what I need to do is print it. So print search on my array, which is numbers, and I want to look for 55, which is not there. So let me save this and try to run it. It returned -1 because 55 is not in the array. Now let's pick another one, which is 9, for example, and I will return number 8. Now if I have 9 back here somewhere else and run it back again, it's going to return 8 as well. The reason for this is we are returning whenever we find any match. So when I found the first match, which is at index 8 right here, I just jump out of the whole method returning that index. If I want to return the last index, I will have to keep iterating and saving the index in some variable. If I want to return all indices that I found, then this will be an array. So I will need to return an array. Now another useful method that's not mentioned in the slides and that can be done easily utilizing those methods is how to calculate the average of those elements. Now if I look at the average. So the average is basically the sum of all elements divided by the number of elements. And if we go here, we already have a method that is returning the sum. So what I can do is I can utilize this code. Remember, methods are all about usability, or basically reusability. So I can just go down here and create a method that is going to calculate the average utilizing my sum method. And when I'm calculating the average, I may end up with a decimal number, so I will be better off returning a double. So public static double, and let me call this method average, or just AVE will do. And what I need in terms of arguments, I don't need anything other than the array itself. So an integer array is going to be my input, and I will go in here inside this. So what I need to do is the following: sum of the array, and then divide this by my number of elements. So the easiest way to get the number of elements of the array is basically by getting the length of the array, because the length of the array is nothing but the number of elements. So what I can do is I can go ahead and manually copy the code of the sum method, which is just rewriting my code. But since I can use that method, I can just say return the sum of my array divided by my array dot length. So this is going to sum up all of the elements, divide them by length, which is the number of elements in the array, and just return it. And I can just go here and call my method and say the average is, and then right here I will just say call the method average on my array numbers. And this is my average of all the elements in the array. So to exercise on this, try to create a method that is going to take an array and return a backwards order of the array. So if I say 1, 23, 45, 6 till I get 9, this is my input. The output array should start 9, 12, 32, 11, and so on till I reach 1. And the way to do this is basically to start from the end of the array. So instead of I being 0, I should start at the end of the array. Now keep in mind the end of the array is length minus 1, so I should start at length minus 1. So try to do this as an exercise. And another good exercise to try to do is to create a method that is going to sort all of your elements in the array by checking whether the element is smaller or larger, and then utilizing the swap method that we created in an earlier video.